Hello and welcome to this webinar on OSPF in 2024, still king of the routing hill. So we'll discuss the OSPF protocol, is it relevant nowadays, and what are the features of this OSPF? Let me share my screen first. So let's discuss about the OSPF and what are the features of OSPF. First of all, we need to understand what is a link state routing protocol and what is the difference between the link state and other protocols. So, say OSPF is like a dynamic routing protocol. It is a dynamic routing protocol, but it is different from its predecessors like RIP, Routing Information Protocol, or say EIGRP, that is considered an advanced distance vector protocol. So, what is the difference? RIP was a distance vector routing protocol. So, it used to have a metric like hop count. But in case of OSPF, we do not use that hop count anymore. Hop count means that intermediate routers. Let's say this is a router, this is a router, and this is a router. So this is R1 and this is say R3. Now you can go via this R2 router or you can go directly this way. Say, or let's say there is no other router here and there is a direct link. So the hop count here is 1 and via R2 the hop count is 2. So RIP used to send packets through these directly connected links because of minimum hop count. But OSPF doesn't use that anymore. It is a link state routing protocol. And link state means that it advertises the state of its links, means the interfaces, the status of the interfaces and the addresses configured on the interfaces to all the neighbor routers. So say there are 10 neighbor routers connected in a network. So it advertises to every neighbor router. It will not advertise only to its directly connected neighbor, because in case of RIP, what happened that RIP used to advertise it to only to the next neighbor, but the OSPF advertises it to all the neighbor. Now the OSPF protocol has a protocol number, because as we know that in network layer protocols, we find that they have the protocol number. Like the EIGRP has protocol number 88 and OSPF has a protocol number of 89. And OSPF administrative distance value or AD value is 110, that is 110. So AD value is what? It specifies the trustworthiness of any route. And say the static route has AD value of 0 and 1. And like say EIGRP has AD value of 90 if you consider the internal EIGRP, that is within an autonomous system, and also 170 you have external EIGRP, of course, and OSPF has 110. So every protocol has its AD value. Then again, we'll discuss the features of this OSPF. And the features are like this. OSPF has two multicast addresses. So definitely OSPF has some multicast address to actually send its updates. So it doesn't use the unicast. It uses the multicast addresses. And the multicast IP addresses are like this: 224.0.0.5, that is all routers, we say, and it is used by the DR and BDR, designated router and backup designated router, to send the updates or multicast updates to the normal neighbor routers. And 224.0.0.6, that is used to send update to the DR or BDR. So OSPF has a concept of designated router and backup designated router. So in an area, we find that in OSPF, we have the concept of DR, BDR, to actually eliminate the LSA flooding. So there are too much LSA broadcast in an area, and in order to reduce that, we have these multicast addresses. OSPF works on digicast algorithm, and it uses shortest path first to build a SPF tree to select the best path. It uses area that is either 16 or 32-bit area. By default, it uses 16-bit area only, but it can use 32-bit area also. So what is the concept of an area? Let's say you have an guided area, say autonomous system. So say this is the AS or the autonomous system, and you have certain blocks within this AS that is called area. So OSPF divides the entire AS into multiple areas. How many areas? It is actually using process ID, that is 1 to 65535. So inside an area, you can have routers running different OSPF processes. And yes, we can have areas from 1 to 65535 with area 0 as the backbone area. So area is actually considered that its job is to also minimize LSF flooding. Now, OSPF supports VLSM, that is variable and subnet masking, that is subnetting, means classless routing. It's a classless routing protocol like the previous RIP. It was a classful protocol in case of version 1. Version 2 was classless, although, but RIP and EIGRP by default it was classful, but OSPF it is classless. Then we will consider the OSPF packets. So let's discuss how many packets OSPF has. So OSPF has mainly 5 types of packets like hello packet, database description or database descriptor, DBD packet, link state request, that is LSU, link state update, and link state acknowledgement. Now, what are those? Hello means that OSPF routers exchange the status of its links within themselves. And they have a predefined hello timer. And it depends on the network type, of course. But in case of broadcast and non broadcast multiple access networks, NBMA networks, it has a hello timer of 10 seconds and dead timer of 40 seconds. Means if two routers are there and they are exchanging the hello packet, that is status information, so the timer is 10 seconds. In every 10 seconds, they will send hello packets to each other. And if they do not get the response from the neighbor routers, then they will wait for 40 seconds, means they will send 4 hello packets. And then if they do not get the response, then they will tear up the connection. Next is database description packets. So DBD packets are actually used to exchange the LS updates. So in case of that exchange phase, so there are some neighbor states that we'll discuss in OSPF. And in case of exchange state, you use the database description or descriptor packets to exchange the LSA updates. Now there is link state request or the LSR packets. Means that if two routers are there and one is finding that the other router has updated database descriptor packet in its LSDB link state database, now the first router asks the second router that you just send me the updates that you have, the more updates that you have. So now the router 2 sends link state update or the LSU to the first router. And finally, the router sends link state acknowledgement after synchronizing its database. Then it sends the acknowledgement and it acknowledges the updates that is sent by the second router. So these are the packets that we see in case of OSPF. Now, let's see the OSPF neighbor states. So there are certain neighbor states that is used in case of OSPF to actually maintain the neighbor relationship, to establish relationship between the routers. So what are those? First is down, then it's init, then it's two-way, then xstart, exchange, loading, and the final is full. So what are those? Down means that the database is completely down. So there is no connectivity, the connectivity is torn down. So the packet will not exchange. Let's say routers are powered off. Init means that hello packets are sent. So it is actually an one-way communication. So one router is sending the init packet, but it doesn't receive the router ID of the other router. So it's a one-way. Now, two-way. Two-way means bidirectional communication starts between the routers, and both routers sees the RIDs, router IDs of each other. Now, in case of IPv4, you can set the RID separately, or if you do not set, then it takes the IP address of the serial interface. But in case of OSPF v3, that is OSPF version 6, that is IPv6 supported OSPF, you have to specify the router ID. Otherwise, they will not establish the neighbor relation. And also, DR and BDR election happens in two state. Now, that is X star. In X star, master and slave election happens. So after the DR BDR is elected, then one router will be elected as a master router, means that say DR or BDR, and other means the DR others. They will be like the normal neighbor routers will be slave. So there will be database exchange between the routers. Now, exchange means the exchange of the database descriptor packet happens in this state. Loading means that it is comparing the database and the missing packets are exchanged. So if some packets are missing in some router's database, so that is updated in the loading state. And finally, full means the database loading is completed between the routers and they are in full state, means the database is fully synchronized. So these are the neighbor states in which the OSPF maintains the neighbor relationship. And now we will configure the OSPF also between the routers. And you can see in this GNS3 console, we have this R1 and R2, these two routers, and we can configure IP addresses and OSPF. So let's go to R1 and let's go to interface, fast Ethernet, and just give an IP address, say 1000. I'm using the default mask, but you can use other mask also because it's a classless. Now it is not taking the say 100, it should be 1. Now we will have a loopback interface also configured here instead of the fast Ethernet. So we are assuming that the Ethernet is now here, it is serial, and loopback is Ethernet. So you give the IP address, say anything. And now go to config mode and you configure OSPF, but I will configure the other router. So in the R1, I gave the 1001, and so in the R2, you go to the fastest side interface. It should be say 1002. And you create a loopback here also. Say it is 3001. This one. And now let me start the Wireshark packet capture also because it's a GNS3. So you can capture the link packets. So it is actually starting your Wireshark here. And let's configure the OSPF now on R1 and R2. Now here you just see router OSPF and give question mark. You can see the process ID comes. So here you give process ID say 1. And you just give the network statements by configuring the directly connected networks like this 1000 and the wildcard mask, that would be the invert of the subnet mask. It is an opposite subnet mask. So 0.255, 255, 255, and will connect it to area 0. And also the other network, that is 2000, and also the same wildcard. And here on R2, you will do the same thing, just you exit and router OSPF. Now you can use the same process ID or others. Say I'm using process ID 2 here. And network, the same thing. And it will be connected to the area 0, that is the backbone area, and then the 3000 network, and the wildcard mask would be the same, and area 0. So the OSPF now should definitely start on the interfaces. And now if you go to this Vasha capture, then you will see that these OSPF messages are coming. You can see this database description packet. You can capture this database description packet, and you can see that this is the open shortest path. First, you can see everything. You can see the OSPF header. You can see the router ID. This is a DB description packet. It is showing you everything. That is the database description, the sequence number. So you can capture the packets. You can even see the hello packet. So let me show you this hello packet. This is actually hello packet, and this destination you can see 224005. So hellos have also this multicast address, and here also you can see this is the hello packet structure that you can actually capture in the Vasha. And here we are not having any DR or BDR. So it is actually showing you the point-to-point link IP addresses, because in point-to-point links, we will not elect any DR or BDR, but it is showing its own IP. So you can have this packet capture. So you can see that hello packets are coming, and also in 10 seconds interval. So this is how, and you can also verify that the OSPF loading is done on both the routers. The syslog messages you can see, and also you can verify the show IP root OSPF. You can see the OSPF root, and also the show IP OSPF, and you can see the neighbor. You can see that the other neighbor, the 3001, and that is in the full state. So actually the neighbors between the two neighbor routers, we have the full state. So this is a simple configuration of the OSPF routing protocol. So that is about the OSPF, the configuration and the basic theory part, the features of the OSPF routing protocol. And still, the OSPF routing protocol is definitely the king of the routing, because in enterprise networks, you often see this protocol, because BGP, border gateway protocol, or other say ISIs, intermediate system to intermediate system, these protocols are actually used in ISP backbone, in ISP, internet service provider networks, not in the enterprise networks, because they exchange a bigger routing prefixes. So if you're having say lakhs of routing prefixes, so in the internet backbone, so there the OSPF doesn't have the features. OSPF doesn't carry, or it doesn't support that much prefixes. But we use the OSPF for EIGRP. EIGRP is also now open standard, just like OSPF, in our enterprise networks, because we do not need the BGP. So yes, OSPF is vendor neutral. It is open standard, and OSPF is still used, because EIGRP, though it is vendor neutral now, in the last 2-3 years, Cisco has made it vendor neutral or open standard, but still the companies are preferring OSPF, because from the beginning the OSPF was used. So they do not want to transit to EIGRP suddenly. So yes, OSPF is still used as the main routing protocol of the enterprise networks. And although the automation has emerged as a new feature, but we see that OSPF has many features, and it has almost 9 types of LSAs, and any filtering we can also do in OSPF. So you can also get that understanding of the OSPF filtering in the CCNP NRC. So this is very important routing protocol nowadays, and till now in 2024, This is the main routing protocol in the routing domain. So I hope that you have got a fair understanding on this OSPF routing protocol, and I have shown you both theoretically and practically the configuration, and we'll come with some more advanced features of this OSPF and other routing protocols in the future. So I hope that you have got an immense knowledge on OSPF routing protocol from this webinar. So thanks for watching this, and we'll meet soon. Till then, bye.